So we're going to learn today, Chapter 8, Section 3, and we're going to learn the last two shortcuts of proving triangles are similar. And those last two shortcuts, the acronym is SSS and SAS. The acronym SSS stands for side, 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 and SAS stands for side, angle, side. These were the same acronyms that we saw when we proved triangles congruent. So let's take a look at the first one, which is the side, side, side similarity theorem. And this one states that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So here we would have to show that all three sides would simplify to the same side length ratio. If they do, then you can say the triangles are similar using side, side, side. So let's go ahead and just check this one out. Now, let's say you weren't given that similarity statement at the bottom and you weren't sure which sides to match. What we can do instead, when you're not given the similarity statement, is look at how big each side is. So if I go ahead and zoom in here to the picture, I would look for the smallest side of the big triangle, ABC, and that smallest number is the 6. Then if I had to match it with the smallest side of triangle DEF, I would match it with the 3. And if you notice in the similarity statement, BC is here, and it is matching with EF. So you can confirm this, and you would state that BC is going to be proportional to EF. Now, you can either, when you're checking for the similarity, you can either write it left to right. I know we've been mostly writing it right over left, so you would have put EF to BC, and then you would have shown 3 to 6, which simplifies 1 to 2. Now let's look for the next biggest side, which is the 8 here and the 4 here. So again, if I do right over left, I would be doing DE over AB. And if you notice, that's the first two letters in my similarity statement. So 4 over 8, which also simplifies 1 to 2. So if you're just checking to see if they're proportional, you don't have to do it right to left. You can do it left to right. It doesn't matter. This is going to be a statement of proportionality where you have to show all the matching sides. So here you could also do AC over DF or DF over AC, either way. And then this one, DF, was 5 and 10, and it also simplifies 1 to 2. Now, if they ask you for the scale factor from ABC to DEF, then you would have had to do this way. But if they would have said, find the scale factor of triangle DEF to triangle ABC, what did they do from little to big? Then the scale factor would have been 2 over 1. So just make sure when they ask for a scale factor, if they specify the order of how you change the picture, you need to pay attention to it. So anytime the picture gets smaller, you know your scale factor is going to be something that's less than 1. But when the picture gets bigger, then it's going to be a number that's going to be bigger than 1 or greater than 1. So this would be, either one of these would be the statement of proportionality. You could either put it either way. So again, understand all of this vocabulary. So either one of these would be your statement of proportionality. Your similarity statement would be this right here. So this is the similarity statement. And then this 1/2 is either going to be considered the side length ratio, which is also known as the scale factor. So when we went from the bigger to the smaller, the scale factor was 1/2. If they ask you for this one, this would have been the scale factor from triangle ABC to triangle DEF. And then this one right here, the BC, this would have been if they asked you for the scale factor or the ratio from DEF to ABC. Does that make sense? It's going to be important that you understand the vocabulary. That's where Algebra 2 gets a bit challenging, is understanding what the question is asking for. Because like right now, my class is graphing polynomials and graphing rational functions, and they're asking them to find the zeros. And when the zeros are rational or even irrational, then it's also x-intercepts. However, when the zeros are imaginary, they're not x-intercepts. So it's a matter of understanding what they're asking for. And same thing here, understanding the vocabulary. Let's go ahead and take a look at our second shortcut from this lesson, which is the SAS, or side angle side. And this one states that if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. Notice the letter A is in between the two S's. So this means that this angle must be the included angle. And remember, that's going to be the angle that's formed by the two proportional sides. So in this particular picture, you would need to have been given that angle A is congruent to angle D, because the sides that are going to be proportional here are going to be AC is going to be proportional to DF, and AB is going to be proportional to DE. And we can use our similarity statement, or again, use the fact that you would match the bigger number with the bigger number of the other triangle, and then the same thing with the smaller number. So notice here, 10 is the bigger number, so I would match it here with the 5. So in my similarity statement, I could say that DF is proportional to AC, so 5/10 simplifies 1 to 2. And then I could also do the smaller number with the smaller number, so DE to AB, 4 to 8, also simplifies 1 to 2. So because my sides are proportional, and I have that angle A is congruent to angle D, I can state that these two triangles are similar using side angle side. So again, you would have had to have stated that DE over AB equals the ratio of DF to AC, and also state that A was congruent to angle D. This would have been what you would have needed to use side angle side. Okay, next slide is just a summary. Again, in our textbook, angle was a theorem, not a postulate. This was actually a screenshot from my older textbook when I made the notes. So all three are theorems. We do not have any shortcuts that are postulates. So again, in order to use the angle theorem, we would need to have shown two congruent angles in our two triangles. And then we could say that they're similar. For the side, you would need to show that all three sides are proportional, that they simplify to the same side length ratio. And then for the side angle side, we would need to use show that two sides are proportional and the included angle, the angle that is formed by those proportional sides. If we can do that, we can say that they're similar, again, using side angle side. For the similarity, there's only 3 shortcuts. Remember back to the triangles, when we did congruent triangles, there were 5 shortcuts, but this is only 3. So let's go ahead and try some examples applying all 3 shortcuts. All right, so here, example 1, it's got 2 parts to it. Now, for example 1A here, notice when they're describing the measurements of the sides, they didn't tell us what side matched with the 4, 5, and 7. So I'm going to tell you that now. So the 4 is going to be for side AB. So AB equals 4. The 5 is going to be for side BC. And then the 7 is for side AC. Notice in the next example, they spelled it out and they told you AB was 2, AC. Now I'm going to do the same thing for the X, Y, and Z. So the 16 is going to be for side XY. And then the 20 is going to be for side YZ. And then the 28 is going to be for the XZ. Now, a picture wasn't provided, so let me go ahead and draw these 2 triangles out. So the ABC is going to be the smaller triangle. Actually, let's put A at the top. So A, B, C, and then I'll draw X, Y, Z. And I'm going to label the sides. So AB was 4, CB or BC is 5, and the AC was 7. Then 16, 20, and 28. It wants to know, are these 2 triangles similar? Notice it does not have a similarity statement, so I don't know if AB matches with XY or XZ or YZ, but what I can do, again, is look at the size of the numbers. So I'm going to look for the smallest number in triangle ABC and match it with the smallest number in XYZ. So I can match it with the 16. So let's go ahead and set that up in a ratio. So XY over AB, 16 over 4, simplifies 4 to 1. Now let's look for the next biggest number. So in ABC, that would be the 5. And it's going to match with the YZ, which is the 20. So YZ over BC, 20 over 5, also simplifies 4 to 1. And then lastly, the biggest number with the biggest number here. So I can say that XZ is proportional to AC, 28 to 7. Divide them both by 4, and it also simplifies 4 to 1. So because all 3 sides simplify to the same ratio, I can say that yes, these 2 triangles are similar using side, side, side. And if they ask us for a similarity statement, we need to put it in the correct order. So we could say that triangle ABC is similar to triangle XYZ. And again, this is your similarity statement. If they ask for a statement of proportionality, then you would have shown and you would have set this fraction equal to this, equal to this. So set these 3 equal to each other for the statement of proportionality. If they ask you for the scale factor, from ABC to XYZ, it would have been 4. If they would have asked in reverse, it would have been 1/4. Let's try the next one. Again, a picture is not provided, so I'm going to go ahead and draw my 2 triangles. So let's try this one, part B. This time, the ABC triangle is going to be the bigger triangle. So let's go ahead. ABC. So AB is 2, AC is 5. Now, obviously, this is not drawn to scale. I'm just trying to give myself a visual to see what matches where. And then here I can put XYZ. And XY is 2.5, YZ is 2, and XZ is 3. Now, they're actually giving me a similarity statement to confirm. And it was ABC is similar to XYZ. So we got to check this. So I can see what matches. I could also use the big with the little, but here AB. And I need to try to match it with XY. So AB is 2, XY is 2.5. So if I go ahead and do 2.5 over 2. Now, whenever you have a decimal and a fraction, what we can do to simplify this, essentially I could move my decimal point 1 time and then move it 1 time here. So then this would turn into 25 over 20 and make it 5/4. Essentially what I did was times the top and the bottom by 10. Then the next side that I need to match, and again, I'm looking for these to simplify to the same ratio. So if I do BC with YZ, BC is 6, YZ is 2. So if I do YZ to BC, this would be 2 to 6. This simplifies 1 to 3. Soon as you find 2 ratios or 2 corresponding sides that are not equal, you can stop and say that these are not similar. Your explanation is going to be this work of how you show that the ratios are different. Even if you would have done XZ to AC, this one is also different. And again, it's not equal as well. So in order for you to be able to use side, 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 all 3 ratios would have needed to simplify to the same thing. I know nothing about my angle measures, so I couldn't have used side angle side or even angle angle. Okay, so for example 2, they're giving us the fact that if triangle XYQ, which is right here, this one on the side, is similar to triangle XZP, can you show that this one, XPQ, is similar to XZY? So let me go ahead and pull these apart so we can maybe see it a little bit clearer. Let me go ahead and pull first the XZP. That one in blue. And then I'll do the red one. And this one is the XQY. Now remember, when 2 triangles are similar, remember their angles are going to be congruent. So let me go ahead and add in the congruency marks. So X and X are congruent. Y and Z, the middle letters, are congruent. And then Q and P. Now, what it's asking me to show is that this one here, XPQ, is similar to the whole big one. So XPQ is, they want us to show, is it similar to the XYZ? Now, I could go in and add in my congruency marks. So I know that angle X is congruent to angle X. I also know that angle P is congruent to angle P. Let's see, angle P, I had 3 marks, and also Q. And then Y had 2, and it was congruent to Z. Now, if you think about this, and I did this in my other classes by adding in numbers, but let me just show you here maybe a faster way that we could have done this, is if you recognize that you have congruent base angles here, then this tells me that these sides are congruent as well as here as well. So let's say we just add in numbers on this, and let's say we show that this is 2 and 2 and 4 and 4. Then what we do is we already have the included angle marked as congruent. And then if we do 4 over 2, the XY over XP, and then the same thing, XZ over XQ, 4 to 2, they both simplify 2 to 1. So yes, they would be similar using side angle side. Now, what I did with the other class is instead of using the space angle information, what I did was at the beginning up here where these two were shown to be similar, I added in numbers that would have made the sides proportional. So let's say instead of doing it that way, I added in a 2 here, and then the side that it was proportional to would have been the XQ. So let's say I scale it up by multiplying it by 2. And then let's say XZ here, I said was 6, and its side that was proportional times by 2, that would have been a 12, and then an 8 and a 16. So then now if I take these numbers and put it into the original, so XP here would have been 2, just to show that it didn't necessarily have to be congruent. And then this one was 12, and then this one was 6. So now instead of using these numbers that I put in, I could have again put 2 and 4 here, and then over here on the XYZ, 12 and 6. It still would have shown that they were proportional, because again, my XY here, 12, is going to match with the XP. Let me see if I matched the sides, and you would have matched XZ to the XP and XY to the XQ, 6 to 2, 12 to 4, 3 to 1. So either way, these two triangles were similar using side angle side. Example 3, let me zoom in here to A. So again, they want us to name the similar triangles and then give, again, it's not going to be a postulate, it'll be a theorem. So it's either going to be angle, angle, side, 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 or side angle side, or they're not going to be similar. So let's go ahead and look at example A here, 3A. So top one compared to the whole thing. So if I pull ADE off, add the 80, and then draw the big one, ABC, B is also 80, Now, I know nothing about my side lengths, so this should be a clue that I'm probably going to use angle, angle. However, I only have one angle that's marked. However, if you notice, they both share angle A up here. So angle A congruent to angle A, reflexive. The angle D congruent to angle B would have been given, and you could have said that in your proof if you were writing a proof. So this would have been, yes, they are similar, using angle, angle by showing angle A congruent to angle A, angle D congruent to angle B, and your similarity statement could be triangle ABC is similar to triangle ADE. It wouldn't have mattered if you wrote the big one first or the little one first. Either way, try to write though the first triangle you list here alphabetically, and then just match the second one with it. It doesn't really matter. It'll just make it faster for me to grade so I don't have to do multiple different combinations. Let's try example B. For that one, I'm going to zoom in here. This one, top one, the CDE. This one has side of 6 and 10. And then the whole thing, the ABC. Now, in order to find the length of AC, I need to add 6 plus 3, and this side is 9. And then to find the length of BC, I'm going to add 10 and 5 and get 15. Now, notice they both share angle C. So now I just need to make sure that these sides that are forming angle C are proportional. And again, what I can do is I can match the smallest number of this triangle with the smallest one here. So 6 to 9 simplifies 2 to 3. And then I can also do the 10 to the 15. And it also simplifies 2 to 3. So if you were writing a proof for this, you would be saying angle C is congruent to angle C. And then you would also show that side AC is going to be proportional to side CD, and that CE is going to be proportional to the BC because they both simplify 2 to 3. So this would have been yes, and the acronym or shortcut or theorem would have been side angle side, and your similarity statement would have been triangle ABC is similar to triangle DEC. Or again, you could have started alphabetically with the little one. CDE is similar to CAB. Again, doesn't matter. Just make sure that the letters where you place them are matching with its corresponding congruent angle. The last one has a bunch of sides on it, no angle information. So this one is a clue to me that I'm going to probably use side, side, side if they're proportional. So again, the top one, LKM, 3, 5, and 6, compared to the big one on the bottom, the KNO, 6, 10. Now to find the length of KN here, I need to add 6 plus 6. So this side is 12. Now again, I don't have a similarity statement to go off of. So again, I'm going to match the smallest side with the smallest side of the other one. So I can match the 3, the smallest side here, with the smallest side here. And again, the order that you put it doesn't matter. If you wanted to do KL over KO, 3 to 6, 1 to 2. Because if you're just checking to see if it's proportional, it really doesn't matter if you do big over small or small over big. Over here, the middle size number will match with the middle number here. So LM over NO, 5 to 10. And then lastly, the biggest number, the 6 with the 12, KM over KN, 6 to 12. All of these simplify 1 to 2. So because they all simplify to the same ratio, I will say that yes, they're similar using side, side, side. My similarity statement, KLM, similar to KON. Again, the order doesn't matter. If you would have preferred to do the KON triangle first and write it alphabetically, you can. You would just switch the order here on the KML. Now, if it asked for the statement of proportionality, you would have set this equal to this equal to this. Now, I know this was the last example, but let me do 2 more examples for you, just to show you another variation of the bow tie, for example. All right, so let me just add one and do 2 more examples. So let's say it looks like this. Looks like our bow tie. So if I have A, B, C here, and then E and D, 5 and 8, and 6 and 10. Now, I know you had something similar to this in one of the homeworks, and you weren't sure where to match. So the 2 triangles I'm going to try to show are similar are this one over here, the ABC, over here to the CED. So again, I have vertical angles here in the middle that I could show are congruent. And then I need to match the smallest number of this triangle with the smallest here. So 5 to 8, and then here 6 to 10 simplifies 3 to 5. Since this is not equal here, this would be an example of not similar. Not proportional, they're not similar. Let me add in an example where it may look like they're similar. So same thing, the bow tie. So A, B, C, E, and D. Let's say I put a 5 here, a 4, an 8, and a 10. So again, I've got the congruent vertical angles. I'm going to match the 5, the biggest number in this triangle, with the biggest here. And then here, 4 with the 8. My sides are proportional, and I've got an angle. However, this is not the included angle, so the way it's pictured, these are not similar. In order for it to have worked, we would have needed to have been given that angle B was congruent to angle E, and then it would have been the angle formed by the proportional sides. So if you were given that angle B was congruent to angle E, then you could say, yes, they're similar by using side angle side. But without this statement, the answer would have been no. So just be careful with the location of the congruent angle pairs. It must be the congruent angle that's marked, must be the angle that's formed by the proportional sides. Yes, we had congruent vertical angles, but it was not formed by the sides that were proportional. So just be careful. So that is it for the notes on 8.3.